Hey there, data explorers. Today we're diving into the world of relational databases, specifically the fascinating world of keys. Imagine a giant library with millions of books. How would you ever find the one you're looking for? That's where keys come in. In databases, keys help us organize and access information efficiently. They act like special codes that unlock specific pieces of data. Pretty neat, right? Now, you might wonder, what kind of keys are we talking about? Good question. We're not talking about your house keys or car keys. In the realm of databases, keys are special attributes or combinations of attributes that uniquely identify each row in a table. They're the secret sauce that makes databases work like well-oiled machines. Just like a well-organized library uses a catalog system, databases rely on keys to keep things tidy and accessible. Without keys, our databases would be like a jumbled mess of information. Keys help us avoid confusion and ensure that our data is accurate, consistent, and easy to retrieve. So, buckle up, data enthusiasts, as we embark on this exciting journey to uncover the mysteries of keys in relational databases. Get ready to master the art of data organization and manipulation. Let's start with the most important key of them all, the primary key. Think of the primary key as the VIP of your database table. It's a unique identifier assigned to each row, ensuring no two rows are alike. Like giving each student a unique ID number. No two students will have the same ID. A primary key must follow some ground rules. It cannot contain null values. Every row must have a value for the primary key. Imagine a library where some books have no identification numbers. Chaos. Primary keys should be minimal. Use the smallest number of attributes needed. We don't want to make our primary key unnecessarily complex. Choosing the right primary key is crucial. It's like choosing a good title for a book. In most cases, a single attribute is sufficient, but sometimes we need a combination of attributes. This brings us to composite primary keys. Sometimes a single attribute is not enough to uniquely identify a row in a table. This is where composite primary keys come into play. A composite primary key, as the name suggests, is a primary key composed of two or more attributes. It's like using a combination lock to secure something valuable. You need the correct combination of numbers to unlock it. Let's say we're designing a database to store information about students and the courses they're enrolled in. We can't use the student ID as the primary key, because a student can be enrolled in multiple courses. Similarly, we can't use the course ID as the primary key, because multiple students can be enrolled in the same course. In this scenario, a composite primary key comes to the rescue. We can combine the student ID and course ID to create a unique identifier for each row in our table. This way, we can easily track which student is enrolled in which course without any ambiguity. Composite primary keys are particularly useful in tables representing many-to-many relationships. They help us maintain data integrity and ensure that our database accurately reflects the real-world relationships we're trying to model. So when one key is not enough, remember the power of teamwork and composite primary keys. Now, let's talk about candidate keys. Think of candidate keys as the finalists in a competition for the coveted title of primary key. They possess all the qualities of a primary key. They're unique, minimal, and can uniquely identify each row in a table. However, only one candidate key can be crowned the primary key. A table can have multiple candidate keys, each vying for the top spot. It's like a talent show where multiple contestants possess exceptional skills. The database designer ultimately chooses the most suitable candidate key to be the primary key, considering factors such as simplicity, data type, and potential for future changes. The other candidate keys, though not chosen as the primary key, are still valuable assets in our database. They can be used as alternate keys, providing additional ways to uniquely identify rows. This redundancy can be beneficial for data retrieval and can improve the performance of certain queries. So, while only one candidate key can be the primary key, the other candidates shouldn't be underestimated. They play a vital role in maintaining data integrity and providing flexibility in database design. Section 5. Foreign keys, building bridges between tables. We've explored different types of keys that operate within a single table. Now, let's venture into the world of foreign keys, the bridge builders of the database world. Foreign keys establish relationships between tables, connecting them like pieces of a puzzle. A foreign key is a column or set of columns in one table that refers to the primary key of another table. It's like a special link that connects related data across different tables. For instance, in our student and course database, the course ID column in the students table could be a foreign key, referencing the course ID primary key in the courses table. Foreign keys enforce referential integrity, ensuring that relationships between tables are always valid. They prevent us from accidentally deleting or modifying data in one table that would break the relationship with another table. For example, we wouldn't want to delete a course from the courses table if there are still students enrolled in that course in the students table. These keys are essential for maintaining data consistency and accuracy across our database. They help us navigate relationships between tables, making it easy to retrieve and analyze related data. Imagine trying to find all the students enrolled in a specific course without foreign keys. It would be like searching for a needle in a haystack. Section 6. MySQL. Queries. Putting keys into action. Now that we understand key types, let's put them into action using MySQL queries. Creating tables with primary and foreign keys. Create table courses. Course_ID int primary key, course_name varchar 255. Create table students, student_ID int primary key, name varchar 255. Age int, course_ID int, foreign key, course_ID, references, courses, course ID. In these queries, we create tables with primary and foreign keys, inserting data, insert into courses, course_ID, course_name, values, 1, mathematics, 2, science. Insert into students, student_ID, name, age, course_ID, values, 1, Alice, 16.1, 2, Bob, 17.2. These queries demonstrate how to insert data while respecting key constraints. Querying data using keys, select s.name from students. As join courses, c on s.course_id equals sign c.course_id where c.course_name equals sign mathematics. These queries show how to retrieve data using joins based on foreign keys. By understanding these MySQL queries, you can manage your databases, ensuring data integrity and consistency through keys. Section 7. Data integrity, keeping your data squeaky clean. In the world of databases, data integrity is paramount. It's like keeping our data squeaky clean and free from any inconsistencies or errors. Keys play a crucial role in upholding this data integrity. Primary keys, our VIP identifiers, ensure that each row in a table is unique and easily identifiable. They prevent duplicate entries, keeping our data accurate and reliable. Imagine a library with multiple copies of the same book, each with a different identification number. It would be confusing and inefficient. Foreign keys, our bridge builders, maintain referential integrity by ensuring that relationships between tables are always valid. They prevent us from accidentally deleting or modifying data in one table that would break the link with another table. It's like making sure that every bridge leads to a valid destination, preventing us from falling into a data black hole. By enforcing these constraints, keys help us maintain data consistency and prevent anomalies. They ensure that our database accurately reflects the real-world relationships we're trying to model. Just like a clean and organized house is a joy to live in, a database with high data integrity is a pleasure to work with. Section 8. Efficient data retrieval, finding what you need fast. Not only do keys help us maintain data integrity, but they also play a vital role in efficient data retrieval. Imagine searching for a specific book in a library without a catalog system. It would be like finding a needle in a haystack. Keys, especially primary keys, are often used to create indexes. Indexes are like special lookup tables that databases use to speed up data retrieval. They're like the index at the back of a book, allowing us to quickly find the information we're looking for. When we search for data based on a key, the database can use the index to locate the relevant information much faster than scanning through the entire table. This is particularly important when dealing with large databases containing millions of records. By using keys strategically, we can optimize our database queries and improve the overall performance of our applications. Just like a well-organized library allows us to find books quickly, a well-indexed database with properly utilized keys makes data retrieval a breeze. Section 9. Conclusion keys. The unsung heroes of databases. As we've discovered, keys are the unsung heroes of the database world. They might seem like small technical details, but their impact on data organization, integrity, and retrieval is immense. They're the silent guardians that keep our data consistent, accurate, and easily accessible. From primary keys, the VIP identifiers, to foreign keys, the bridge builders, each key type plays a crucial role in maintaining the integrity and efficiency of our databases. By understanding the different types of keys and how to use them effectively, we can unlock the true power of relational databases. So, the next time you interact with a database, take a moment to appreciate the behind-the-scenes work of keys. They're the silent partners that make our data-driven world possible.